All right, let's take the code we have and let's put that on a paste bin somewhere so that you can get to it if you're following along. And we'll update the the URL for what we're doing as well. So let me just get this back into working order. Okay, so that works. Let's go up to the top of this code. I'll put a breakpoint here because this is where I want to come back to. We need to come back to that eventually, so we'll keep that there. We don't need to come back here. So right here and here we need to come back to. Up here, so we have a to-do for what the links here need to be. I'm going to go to pastebin and put that in there. So okay, so make some notes. Make sure that runs after I've made the notes. Okay, so in pastebin, we'll just paste all that source code. We'll change the syntax hiding to GL shading language, and we'll name this SDF 009, and we'll create a new paste. Okay, so now that we have that, we're going to edit it really quick. And we will, now we have that pastebin URL. So what we can do is we can put the pastebin URL into our documentation, and we can remove that edit because we're not in the edit mode. We're just, in pastebin. And for the tiny URL, we still need that. So let's go to tiny URL and fix that. So I'm going to update that, save changes. www.tinyurl.com. We're going to make absolutely sure that this pastebin URL is correct before we make a tiny URL for it. Okay, so that link looks correct to me, SDF 009. And so we'll go to here. Okay, and we'll make a tiny URL. And actually, we need a dash here. Make tiny URL. Okay. So now with that, we'll take the tiny URL and we'll do SDF-009. And I mean, the tiny URL is good enough to let me know this is SDF 009. I'm not going to worry too much about that. We'll save it like that, and then we'll go back to edit the pastebin post so that it'll go to that code. And save our changes. And then lastly, I'm going to take the pastebin post, and I'm going to make sure that when I cut and paste from the pastebin post, I want to be able to get some working shader code in ShaderToy, right? Okay, so that all works, and I'm ready to continue our refactoring. So I think a good idea for these error codes would be some hex values that are sequentially ordered in a way where we can automatically just know what the error is by seeing the numbers. So I'm thinking that we could do something like this, where error number 1 strobes between these two colors, and then different errors kind of do the same thing, strobe between two different colors. Now the problem is that we're probably going to have some convergence where the difference between these two colors is going to be smaller and smaller and smaller as we continue. But let's just try this and just see what happens. So, you know, 1 in hex is, so let's see how we did this before. So we did, so we're going to take 0, 1 like this, and we're going to say equals 1 divided by 250, 1.0 divided by 255, 255.0, and then divided by, or actually, no, 1.0 divided by m, right? Which is the max. But actually, we want 0x, 0, 1 divided by m, right? Yeah, and then, so f32, 32m equals 255, max. So max intensity is what we're going to do. Okay. So m for max intensity, and we'll set it to float 32. That is 255, right? And then we'll divide these different values by m to get what we need. So we're going to do 1, 2, 3, and actually, no, what we can do is we're going to do something like this. So we're going to do, so if we do this, 0x10 divided by m, we take that, and then we do a, we get a find and replace template here really quick. And we're gonna go 0 to 9, right? Or 1 to 9. So we're just gonna take this, and then we're going to look for 1 in any place we find 1. We're going to replace it with like a 2, 3, 4, 5, 6, 7, 8, and 9, right? So this is kind of like the information we're going to use to cut and paste really quick. So, okay, so now we've kind of cut and pasted, and we've created this kind of array of numbers. And, you know, should these numbers be directly here? I don't know. Maybe not. It is definitely quite a lot of bloat, you could say, for being in this section, but we'll worry about refactoring it to a better place later. So now for these right here, right, we're going to create these by, oh, actually we want some underscores in front as well, so let's do, we're going to create these by taking the numbers and just mashing them together, right? So we're going to do like 01, 01, 01, and then A for alpha or something like that. So if we look for F32, we could do A equals F32, and this is 1.0 alpha max. Okay, so let's make sure we don't have the A variable kind of like around here. So it's a very terse variable. We want to make sure we're not using it anywhere else in this function. Okay, we'll just take A, and we have enough room to where if we wanted to, we could alpha, right? So ALP for alpha. So we could do ALP. And then for M, we could do max. And really quick, you just divide by max like that. And then really quick, we could kind of hackish and ugly, but you know, just that way I don't have to worry about that variable name later. I can just, if I ever want to replace all of these with another variable name, I can just do this. And I don't have to worry about removing whatever duplicates are on the empty line. So we'll just say max. And then right here we have this alpha, and so this looks good. So we have these hex values that we're creating by taking an RGB hex value and then dividing it by dividing it by the max. And also, I realized something I'm missing here. Remember that these are going to be interpreted as integers, but we need to interpret them as float 32. So we got to do float 32 like that. And like that, okay? So max is already a float 32, so we're good there. Now, the next thing we need to do is just mash these values all together, right? So we got these values with the alternating 1s and 0s, and then we're just going to do the same thing with like 0, 2, 3, 4, 5, 6, 7, 8, and 9, right? And since this is very regular, let's just check this for syntax errors right now. Make sure this still works. And as long as that... Okay, so it doesn't. Let's see what kind of mistake we made. So, underscore 01, undeclared identifier, assign, blah, blah, blah. Okay, so our syntax here is wrong, right? We need to actually say something like... this is a float 32, right? So float 32, and then the actual variable name, right? And for here, I guess we can now have to do this again, where we kind of like comment out all of this. Which that's kind of tedious, but I'd rather have things look really nice, so we're gonna do that. Okay, so that also means that this also is a float 32. So float 32, and now we are running out of room. Now we could change how we could, like, you know, sacrifice one of these spaces here. That could be a thing we could do, or we could just make this back into an A, right, instead of max, right? I would rather just make this into an A, because I don't really care about that channel, and then we can also have that extra space like that, and I think that's better. So for the alpha, we'll just change that back to an A. Okay, so with that, let's take that to the compiler, and let's go check that out, see if that works. And no, we made some other mistake. Let's see what we made. Dimension mismatch. Oh yeah, I don't know why I did that, but this is obviously a vector 4. Okay, so now when we look at that, okay, so that is compiling again. So I'm pretty confident that these are kind of like what we need. So we're going to take this, and we're going to get another template to duplicate this. So we're going to take this stuff here, and right away I see a problem is that actually, no, because the 4 is not a 1, so we should be okay. So we're going to take we're going to look for 1s, and we're going to look for 1s, and we're going to replace it with 2, 3, 4, 5, 6, 7, 8, and 9, right? So let's take that and run it. Okay, so now we have these duplicated code blocks, and it's all the hex codes we need for these errors. So what we're going to do is just... these are like our error colors, right? And we have this like table of errors right now. But what we want to do is we want to have two tables of errors. We want to have table 1 and table 2. Alternatively, if we don't want to do table 1 and table 2, we could have message error and then message error times how many errors there are, and that would also work. And we got to think, well, what's the most sensical way? Now, having these next to each other actually makes sense. So, right, so we have this table of errors. This is error 1, error 2, right? So, like, that, like, makes sense. So I'm thinking, first of all, let's make sure this still works before we continue. Okay, still working. Now, the problem with having just one table of errors and just doing some math to jump to the correct index is that that's a little bit too clever, and that could that just makes the logic harder to follow. And so I think we should do table of errors 0, 0 and table of errors 0, 1. And one will be for odd errors and one will be for even errors, right? So let's take this, and we have all these values, and we'll just take them in 1 through 9, right? So we can go like this, and we don't need to do this vector 4 stuff. 0 is invalid error, right? We wouldn't have any contrast if we were alternating zeros. So yeah, we'll take that and we'll just duplicate it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can just do 2. I don't know if this is the slower way to do it or not, but so the thing is that we'll probably need more than we'll probably need more than 10 errors in the future, but this is a good start, right? So table of errors 0, 0, 0. So this is going to be for these are darker, right? Because this is a 2-digit hex value for the color channel, and this is just 1, right? 1 out of 255. So these are very dark colors, so we're going to use 0 for odd and for dark, right? And then we'll do the same thing with so we'll just copy this and table of error messages number 0, and then we'll have table of error messages number 1. And it's going to be declared exactly the same, right? Everything's going to be pretty much the same. 10 vector 4s. But then we're just going to shift everything over. So we could actually just do this. We could just remove the 0 from that side and put a 0 on that side, right? Like that. And bam, we got like all the variables we need, right? So now the next part would be making sure we know what this is like right away could be helpful. So I know we have like these defines for these errors right here, but it might be helpful to we could put the defines. Let's not worry about putting the defines in a different place, but let's take these messages and let's put comments for what all these are, right? So this is error 1, error 2, error 3, error 4, error 5, error 6, error 7, error 8, and error 9, right? And then and what this is odd frame, right? Because we're going to try to make this strobe, so it's like obnoxious and annoying. Even frame. We're just going to call it Eve frame, and hopefully you understand that Eve frame is even frame, right? Because we're running out of space. So even frame, and then even frame error colors. And then these right here are odd frame error colors, right? Odd frame error colors. Okay. So now that we have all that in there, this flux thing, we're kind of flux is a variable that's kind of like going back and forth between something. So we're doing this like mod itime, whatever. And the idea was to like make it strobe. But for now, we're just gonna get rid of the flux variable. Or actually, yeah, we can get rid of the flux variable. And well, we have a strobe thing here. So yeah, okay, we'll keep flux, but we're gonna limit how we use it. We're gonna try to standardize some of this. If we are using an invalid error code, we want something that, instead of having these these are basically all different grayscale strobes. But if we have like an invalid error code, we want something where it's like obnoxiously. So what we're going to do is we're going to say 0x F8, I don't know, 0066, I don't know, 666. Yeah, let's see what that color is. Hex color picker. Let's see if we can find a hex color picker online and see if we can find okay, so with this hex value, if we just take this hex value, and we just want to make sure that it's like a hex value that, okay, so it's this magenta-ish color, that's good. And let's take, if we did something like 0x and then, I don't know, 6660000FF, 0FF. Kind of like FF and then a 066 like that, but let's make sure that that's still like a color that that we're satisfied with. So okay, not much different. So let's take this other one. Okay, so it's gonna flash between red and blue. Are we okay with like flashing between red and blue? Well, I do like that these numbers will be easy to find. So, you know what, we'll go with that. So, we'll take the red flash, and then over here, this is a blue flash, right? So, this is a blue flash, right? Because the blue channel is the greatest channel. And also, let's normalize our variable names here. So, we have a underscore after it as well. So, take that, and then where we're kind of like declaring everything, I don't know how we want to do this. I guess what we should do is we should just, yeah, I don't know where we want to put that. Do we want to put it like, we'll put it in the middle here, right? Okay, so it's a float 32, here's the variable name, and it is equal to, it's equal to a, this is not a float 2, this is a vec4. And it's equal to taking a vec4 constructor and just loading it with, we gotta load it with, FF06 and 66, right? And then, actually, we have enough room over here, don't we, that we can just keep it on the same line, yeah? Oh, and then also the maximum alpha, right? And then we need another one for the 666 0FF, right? And then pretty much that's just the same thing but inverted. So we have a 66 like that. And then we have a underscore, but then instead of a 06, we got a 60. And then we also still have the FF, right? And we forgot some of our underscores on some of these variables. So, okay, that looks good. And then what we'll do is we'll just say float 32. And we need a FF. And that equals F32 0x FF. Divided by max, and we need 4 variables. So let's take that, and we'll take this. So we have the inverses of each other, and then we have one with all 6s, right? And so we can just go down here, select like that, paste that in there. So now we have variables for each one of those bytes, and we have the 2 invalid invalid error code strobing colors. Okay. So red plus blue flash. Okay, so... Oh, another thing we could probably do is you can probably do this and make sure each byte is in the correct place. So, okay, that looks correct. Let's try the bottom sequence. So if we look at the bottom sequence, that looks good. And that looks good. And that looks good. Okay, so that is all set up. And put error code error code. So these are error code strobe colors. So we can take that and kind of like make a section divider here for that. And technically, it is still the same thing over here. So that is where the section ends. Okay, that's good enough for me. So let's make sure that everything's still running. So we screwed something up. Not happy about that, obviously. Well, why would you be? Let's see, we screwed up here. Table of errors. Oh yeah, so we did all this refactoring and whatnot. But we have a mistake here where these are now two different tables, right? 000 and table error 001. So if we look for where we're referencing table of errors, right here, we need to kind of fix that up. So we have this kind of modulus that looks like... So this is redundant here, this and this call right here. So what we really want to do is this modulus value was like a decent modulus, I believe, for the strobing values when I tested it last. Or when I observed it last might be more correct. So we're going to take the table of errors and we use, this is a floating point modulus, so this is why we use a less than 1.0, because I found it just did not work when we used a non-modulus. When we used whole numbers, it just completely failed on me. When I look, like, strict equality to 0 was just failing. So I just did like this. I increased the range to get it working. So let's take this and put that in there. And then we'll take this and put it in there. And then we're also going to have to observe the effect somehow. So we'll have to like hack up some of the code for a temporary amount of time just to make sure that everything is working. So the table of errors, we'll use this table, and for the odd, this table for the even, and this it will create the strobe selection. And this is, if we totally don't expect it, then we're going to end up here. That's still going to create some problems for us because, you know, we need to, we have to actually be able to identify all the hex values. So let's, we can get rid of this. And we're out of our column limit here. So we need to figure out, well, how are we going to simplify this? And we could use just a define really quick and make something else shorter. That, or we could just indent, right? We can also indent, right? So we could indent in a way that makes sense. I don't know if that is the most sensible way to indent, but we could we could do that, right? So and maybe that's the best solution, because defines are also going to add more code, like vertical code. But then they're going to also add mental indirection. So just changing our formatting a bit might be the best way to do this. But also it might make it a little bit unnatural to read, because somebody looks at this random thing and they're like, that makes absolutely no sense. How is that even possible, right? And it's like, oh yeah, because there's this right here, right? So I'm going to keep it like that. because we can see it, and then we're going to have to get rid of this. We're going to have to actually create a hard-coded hex value for this as well, just because we don't want any values that for indicating errors that we cannot instantly locate in our source code. So let's see what the next problem is. Assign L value required, can't modify a const. Okay. Oh, you know what? So I think there was some... yeah, so these defs right here, I think I redeclared them, right? Yeah, so FF is definitely redeclared. So we can get rid of these defines, and hopefully we don't, like, destroy anything. But let's get rid of these defines. And they were helpful while they lasted, but now they're just colliding with stuff. So let's take that out, and let's save this and see what we got. Okay, so what's the problem now? And 06 redefinition. Okay, so underscore 06 is being redefined. So that makes sense because we have this 06 here. And then we're trying to like reuse it here. So to fix that, I'm just going to go like this. I'm going to take this, and now that kind of solves the question of where I wanted to put this block, because now it makes more sense to be down here, where it's not where it can re-reference this, because that's already defined, and invalid error code we'll call it forgot to init colors. Because really, really what this, when these colors show up in our code, it's because we probably forgot to init the error variable, or I don't know, maybe that's not the best, error 0 colors. And it's actually for error 0, so let's just call it error 0. Error 0 is an invalid error number, right? So when you like malloc something, or when you calloc something, right? You zero initialize a variable, it ends up with the value of 0. So I tend to like to use 0 as meaning undefined, or that way I know when I made a mistake. If I use 0 for something meaningful, which sometimes I do have to do it that way, but if I'm not, but if I can afford to not use 0 to mean a meaningful selection value, then I always like to use it as like an invalid enumeration value, so that I can catch when I forgot to initialize a variable. Now, can we get a little bit of extra indentation in here? And we're like really close, but not quite. So if we really wanted to, we could probably do this. We could probably do this, like define f and define it as float32, or it's just float, right? And then define v as vec4. And if we do that, we can get a few more characters of space and just get in there. So undef f and then undef v, right? So we just want a temporary define so that we can have a little bit of less column space there. So that works. It's still kind of using up a little bit too much space. Could do this, and then tab, 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 tab. So we want to be like about here. So we need to do 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So getting a little creative, right? But the idea is to kind of maintain this indentation and maintain this section. We really don't care about this, right? We can look at these and kind of know what it is. This is information that does not need to be shouting in our face, because it just doesn't need to be there, right? We know it's a data type. We don't really care about the data type unless we're debugging, right? We just care that, oh, these are hex values that are used as color values for pixels. That's all we care about. So so then what we can do is we can make a little note if we wanted to. We could say invalid error colors will error color for getting if you forget to set error code, you will see flashing red and blue hex code. Okay, so that's good for me. So 0 error colors and error 0 colors, and then red and blue. And this is the red, this is the blue. So we want to keep that order. So red then blue, right? We want to do that respectively, even though we didn't write respectively. We should assume respectively if we're being very consistent with what we're doing. So that looks good. Let's make sure that everything's still working, because you never know what we screwed up. And we've made some more mistakes. Let's see what we got. Something down here. 06 is still redefined. So I know why that was. It's because oh yeah, because both of these are already defined, right? So I need to comment this one out as well. The reason I'm keeping them here is just for a reference, right? Because so that this is kind of like a self-contained block, but they're already declared up there. So let's just comment that out like that, and that should be good. And let's rerun this. Okay, so it's running again, which is cool. And what I would like to do now is before we kind of like continue and, well, okay, before we have any fun, we really need to address this guy right here. This thing. This color, I have just glancing at that, I have no clue what color that is. You know, maybe it's like 128, 128, 0, and then, oh wait, not that anyways. It's some random variable, 128, 0, full alpha, right? But that vague notion of what this color is not enough to just be like, Control F, find that color, right? So we need to be stricter with what that is. And I think we got rid of all the other ambiguous colors. So with that, we got to think, okay, well, what do we want for this? And I see that I mentioned that this is like an orange strobe for an OK value that is not expected. So, okay, so now we kind of know what that is. And it's because in this big block, you'll see that it's surrounded by OK. And that is because we want this pixel air function designed so that we can call it multiple times. And the first time it's called is when it actually does something, and every time after that, it doesn't do anything. And the reason for that is because after the first error, everything else is just an invalid state, and we only really care about the first error, right? So we give a error message as just one of these integers here. We give the original pixel, the pixel color, and the pixel color is like an error message, so previous pixel error or the current pixel color, whatever you want to call it, and then this OK value. So the OK value is initially going to be 1 for everything's OK, and when we call this function, we're going to decrement OK with a post increment value. So the first time this is called, it's going to be 1 equals OK, and then every time after that, it'll be OK is less than or equal to 0, and it'll just assign the original color. So the first error pixel color will be set, and it'll never change after that, as long as we call this function correctly with the correct idioms that I have established. So with that, if we do not use the correct idioms, And then instead of having OK less than 0 and OK equal to exactly 1, and we do something stupid, like start with OK equal to 7, if OK starts equal to 7, then when we decrement at 1, it goes to 6, and then OK is still a positive value, which would be a truth boolean if we assess it as a boolean. But we don't have any conditions for that, right? We got less than 0 and we have exactly equal to 1. And if we have anything else, right, if it's any other condition besides that, we want to make sure that we are notified that we screwed up our logic in how we called the error pixel function. So this is like a meta error. It's an error with an error upon an error, basically, right? Because the error happened, and then you get an error that you called the error calling message wrong, right? So with that, we know that the comment says that it should be orange. So we could kind of like duplicate this kind of block and say that bad OK error. So let's just do that. So we'll just call this bad OK error. So this is the bad OK error color, right? And then down here, we'll paste that there, get rid of one of those. And using an you will see this if you init OK to a value other than 1 in your source code. So now the problem with this is that the worst possible thing that could happen with calling this function, is if OK before I called this function was equal to 2, because I'm going to, well, actually, no, that'll be okay. Nah, we'll be okay. We'll be okay. We won't have that problem where OK gets decremented to 2, and if OK starts out at 2, we decrement it. We call this function. It's called with a 1, and 1 is a valid value, and then we don't see the error with the OK value. I don't think that'll happen. So you're going to see this value if you set the OK value in the code to a value other than 1, right? So I use this kind of pattern similar to like a JavaScript promise, where you have like a if then kind of thing, where you're trying to make all these if statements very linear, but they're all these ifs, but they're asynchronous, right? And you're trying to take all this branching and make it linear. So I do the same thing with the OK value for code that ends up code that would otherwise branch a lot. I wrap a whole bunch of things, a lot of blocks of code in an OK variable, and at the top of the function, I'll set OK equal to 1. And then I'll wrap a whole bunch of different pieces of sublogic in that function into a block that says if OK is greater than or equal to 1, right? And that way I can get rid of a lot of extra nesting in my code by doing that, if that makes sense, which probably doesn't, because I'm not good at explaining things. So let's take this, and we want some type of orange strobing color. It would be nice if we could get some type of value here that is sensible. It could like so red and green is going to give us like a yellow or an orange, depending on how we balance that out. So, or a lime, right? So if we have red and green, that's yellow, and with a little bit less green, then it's going to shift more towards red, right? So this should be an orange value. So let's take that and see kind of like what we end up getting here. So I'm going to put it in a hex color picker. Okay, so I like that. It's kind of it's a pure orange color. And then let's try the same exact thing, but we'll do like do we want to keep it like, if we do 77FF, we're going to get lime, I believe, right? If we do that. I think that's a lime color. So let me check the color picker. Oh yeah, so that's like a lime color. Well, it's an obnoxious strobing color, that's for sure. So I do like the idea of just kind of like strobing like that. And do we already have 77 declared? So FF is already a thing, right? Yeah, because it's already declared right there. So we'll comment this one out. And what we want now is we want like a 7-7, and yeah, we just want a 7-7, right? And then we'll take the 7-7, we'll put it over here. And 6-6. Okay, so with that, we got the 7-7, and we just want to plug it into the correct places. So FF, 7-7, and 7-7, and that's not quite correct, is it? No, this is supposed to be a 0, underscore 0-0. And do we have a 0-0? I don't think we do. So there's no 0-0 variable, but let's make that. And we'll just duplicate this, and FF7700. So kind of like in the order that it's first used. And we will take that, and then we just need 77FF, and then a 0-0 like that. Okay. So we can make sure that these are correct. So we can color code, check the top. So cyan, orange, yellow. And then we can do the same thing for here. Just be really paranoid. Cyan, orange, and yellow. Cyan, orange, and yellow. Okay. So with that, I like that. And we might want to say, like... So really what we could do is, if you see this... Okay, if you will see this if you init OK to a value other than 1 in your source code. Strobes between orange and lime. And then, you know, hex codes here. And we're going to need more room for those. I just know we're going to need more room. Well, I could be wrong, but I'm pretty sure we're going to need more room. So we'll take these and put them there like that. And yeah, we need more room. Okay. So with that, we can... Yeah, that looks good. Okay. So now we have nice little comments. We got our 7-7, we got our 0-0. FF was already declared, but we use it there, so I just want to know what that is, so I put it there. Okay, so that looks good. Let's take that, and we're going to just make sure the code still runs. And it doesn't. God damn it, what did I screw up now? I always screw something up. Oh, okay, so something is wrong with my block comment, and, oh, yeah, well, that would be a mistake. Okay. And taking this and taking that for a run. Okay, everything's working again. And so I'm just looking at the printout, okay, there's that white, okay, there's that green spot. Okay, so okay, we're good with the voxel volume. Voxel volume still looks correct. And now we can take this strobing value here of the orange and lime strobe, and we can put it into here. And the way we're going to do that is we still need this like mod stuff, but it's I'm going to just select between one color or the other color, right? So let's just paste that there because we're going to need those. We'll take that. And we'll open this up a little bit, give us some space. And, you know, it's either this one or it is this one, right? Okay. And then we can get rid of this. And, you know, I do like to... Okay, that's good. Have some space there. And this is orange, and this is lime. Just for a note to know what colors we're looking at there. And up here, I would rather that, for a lot of these comments that I have here, I'm going to remove the semicolons so that I definitely like it that, oh, that's bad. Are we off by, oh, it's the comma. Let's change that a bit. Let's, align the comma with that, like that, and then we'll kind of like, there we go. Same thing here, so we'll fix that up a bit. And then we can just go Shift-Tab. Okay. And what I'm doing now is I'm just kind of getting rid of... I want a... kind of like a color hierarchy with my code. So this blue is, you notice I don't really use autocomplete or any syntax highlighting on keywords, because I really want the comments to kind of like tell me like what sections of code I'm in, you know. So I don't want too much visual noise, so I kind of have to choose, I have to prioritize like what do I really care about, you know. So we can comment that out. And you can get rid of that. And then same thing with this. Let's just get rid of the semicolons there. Okay. And we'll do that. Okay, so that looks much nicer visually. And make sure we didn't screw anything up, because I'm good at screwing things up. Yeah, so I already screwed something up. So I just made some what I would consider trivial changes, and then I still ended up screwing something up. So always, you know, change a little code, check it out. Change a little code, check it out, because you never know what you've screwed up. So I see that undeclared identifier. So this is undeclared identifier. I think we are probably declaring it in the wrong scope, right? Maybe. So it's declared right here, but you'll notice that this is in a different scope, right? So what we could do is we could take all of this out and put it somewhere else, right? We could... that would be the easiest way to do it. And then we have just the logic rather than all this variable declaration stuff. That kind of makes more sense to me. And right, we have this table of errors. We could keep that. Well, this is the only place I want the table of errors to be called from. So we'll keep this big chunk in here, even though it makes this kind of less concise. And we will take out, we'll strip this out. We'll strip all of this out so that we can reference it from other places. So we'll take all that, and we'll just go bam, strip that out. And we will go, I don't know, here, I guess. Paste that. And then we can also section this off. We can say, like, well, what is this section? What is this all about, right? And we'll just say, unique hex codes for unique hex color picker debug hex codes. You know, I don't know. Color picker debug hex. I don't know. I mean, that's probably a good enough name. And then down here, where that section ends, we can, right, so that we know what this is for. And then we can kind of describe, well, what is color picker debug hex? And we can say, you know, make it easy to find a source of error in code by using color picker on shader output, and then doing a ctrl plus F with that hex code on make it easy to find source of error in code by using color picker on shader output, and then doing a control F with that hex code to find the offending source code. Okay, so that's kind of like why we're doing this. Okay, so with that, let's make sure it still runs. Well, not still runs, because we had a syntax error from variables being out of scope. So that ran, that compiled correctly. So we're good there. So that's nice. This is out of control. This is almost 1,000 lines. And this is why I'm not going to like try to write this from scratch again, just because it's getting too much for me to be able to rewrite. Like, I did enough practice sessions where I kind of understand what I'm doing, and we just don't have the time to like redo it all over and all over again all the time. So, not to say that burning something to the ground and starting over is never a good option, because it's often a good option. Okay, so let's get rid of some of this. Actually, we don't gotta worry too much about that. Let's see where my bookmarks are. So let's get rid of this bookmark. We can get rid of that. And this is the only bookmark that's left, and this is where we want to be. So this debug here, this debug value, we're kind of animating it. And what I would like to see right now is I'd like to see something, I don't know, interesting. Let's have some fun with this. Let's what if what if we had this plane kind of like what, I guess I don't know, let's not do anything too fancy, but what if the plane bent on only two sides? I don't know. So what if A and D were the only sections that were kind of like fluxing, right? So we'll take that, and so now it's no longer going to go, the plane's no longer going to be like moving up and down. It's just going to, these 2 points B and C are going to stay in the same place. Well, A and D kind of like flap up and down. We're going to just see, hey, what does that look like? That probably looks cool, right? I'm expecting to see like a more symmetrical warping where there's like a little warping in this top corner here and then a little warping in the bottom corner. So let's give that a run and see. Oh, hey, that's kind of cool. So yeah, what we're looking at is we're looking at a cross section, right? And the reason why the cross section has these like curves in it, as far as I understand, is because this plane here, right? This is you need 3 points minimum to create a plane, but we have 4 points, which means we can create these polygons that are not valid planes, right? So we're thinking of this as like a cutting surface, right? a surface that's going to like a slice plane. We're thinking of A, B, C, D as a slice plane. But if we use bad values for A, B, C, and D, then these points A, B, and C, D will not be coplanar, right? They won't lay on the same plane. And so what you're seeing is the result of slicing through the space with a non-planar plane, right? And not like a curved plane, like just like a plane that kind of like has this weird. Well, actually, maybe it is a curved plane. Let me think about that. Um, yeah. So yeah, it would be a curved plane, wouldn't it? So how do I explain that? So imagine, uh, let's go to. I have a camera. Let's. Oh god, it's a disaster. But let's go to the camera and try to draw something really quick. now let's go back. So I'm gonna put away the camera. So with that said, it's pretty cool that we can like slice in these kind of like curvy, weird ass ways. But it would be nice to have a slice plane that's actually like logical. And before I do this, I need to fix something. I have right now that text says that it is so that text is not correct. Hold on. Okay, so if I need to change that text really quick, so hold on. So my source URL. Okay, my source URL needs to be 009. Okay. Okay, so right now the source is at tinyurl.com/sdf-009. Just so you know where to find that. Okay, so save changes. Okay, so where was I? It's nice that we have this, but it would make more sense if we can mess around with a slice plane that is, well, planar, right? Because right now we're kind of like debugging this, and we have this stuff, but we don't really have anything that really makes sense. So the first thing I want to do is I want to change this back to just H's for the height of the camera, and then we're just going to get nothing's going to animate anymore, and it's just going to look stupid, but it's going to be what we expect, right? Okay, so with this, I would like to try to figure out where those solid blocks of color are coming from, and I think that they are coming from this plane when it is inside of a negative coordinate space. I think the negative coordinate space is giving us these checker values that are it's not giving us any checker values. It's just giving us this like solid gray. And so something is wrong with our math for when we select the checker color. But first we got to make sure that my assumption is correct about it's the negative coordinate space that is causing because I don't even know if that's correct. So we can straddle different coordinate spaces, and like let's straddle the XY, the XY origin, and see what those different quadrants look like. The positive, positive, the negative, negative, the negative, positive, the positive, negative, and let's kind of see what the checker pattern looks like in all of those different quadrants. So for that, we have this polygon we're building, and we need to add like a translation. So we're gonna run out of room like really quick. So we gotta just we gotta move this diagram. So we're gonna take this, and we're gonna make some room here, and we're just gonna paste it there because right now we're about to run out of some room. So I'm gonna take that, and I'm gonna work with my color hierarchy where I kind of now you might say this is kind of clutter, maybe this should be an offboarded comment, and that might be true. So if we see this comment that's already offboarded, it doesn't have the actual diagram for it, but we could offboard this diagram to this comment as well, maybe. But for now, I kind of like having this diagram just because I can reference it easily and instantly I know what it means, you know. We could maybe center it a bit. Okay. So these values here are going to need a translation. So we're going to need like a tx and a ty, and I think that we already used tx, ty for tile x, tile y. So we might want to be more verbose, or something. I don't know. We could also use like offset x, offset y. That could work. Or I don't know. Well, I'll do what I do in a lot of my SCAD code. So we'll do like this, and then we'll add like x offset, ZOS, plus YOS, and ZOS plus YOS. ZOS plus YOS. Okay, and then also this height, right, XY, so this would also have a, if we wanted to, like, we might as well just be... Right, so this is just a translation that we're going to apply to this plane. And from there, we can kind of just set what those values are. So we could say float 32, ZOS equals 0, F32 0. I don't want to have to write 0.0 all the time. Okay, so take those and then just, replace Y and Z here. And, no functional change should have happened yet, right? We just kind of like added some more stuff, but we've set it to 0, so we shouldn't expect a change, and I've made some type of syntax error, so let's see what we've made. Plus, wrong operand types. Oh, got ya. So because we did that, so this is already inside of a constructor. So we can, so if we want to keep it like this, we're going to have to, so really, we're in this voxel space, and our coordinate space is all in pixels, and our tiles are measured in pixels. So I don't see any need for this to be a float 32. So I know that these are end-up floats, but we'll just use I32. We'll use ints. And now it's an int plus an int, and that'll still work. So let's just run with that, see if that compiles correctly. And now I'm getting frustrated. Okay, let's see what we screwed up here. So it's probably still the same thing, where we're kind of like mixing and matching variables that we shouldn't. And so maybe this H is... Oh, the H is already a float 32. That's right. Oh yeah, and Y is a float 32. Okay, so it's just the 0 that's causing... Okay, so it's the 0 that's causing the problems. All the other things are float 32s. And because of that, we're going to have to... like, make these... we're just going to use underscore for 0. And have we used an underscore variable here yet? Nope. So we're just going to say F32 underscore equals F32 0. And we'll put that somewhere else. Okay. And that's kind of obnoxious, but let's give that a run. See if that fixes it. Okay, so that fixed it. Now that we have like these translation variables, what we could do is we could take the debug variable, and we could just add a x and y offset. So on this x and the y, we'll just plug in the debug. And now we're going to expect the whole canvas to kind of like move diagonally, right? Because we're basically translating the viewport, right? So now we can see that, yes, indeed, we have this viewport, and it's kind of like going to rock back and forth. And what I'm concerned about is, as we rock backwards, are we going to like start to see like some type of solid coloring? And no dice. Okay. So we got to think about was I mistaken about, let's make sure I'm not mistaken about um, the height values. Like, I don't know, let's just plug that in there, see if we can get some interesting stuff. And woo! Okay, so that color right there sure looks like it's not checkered. So what I want to do really quick is I'm gonna get I'm gonna get out my snipping tool that comes with Windows right here, the snipping tool, and I'm going to wait for that solid block of color to show up. And we're just going to make absolutely sure that that is a solid block of color and that it's not. So yeah, right there. What are you? So that looks like a solid block of color. I'm going to check on. I think I reloaded my shortcuts so I can open the color picker from my shortcuts now. And that looks like it's working. So we want to see what's going on with that. Like, it sure looks like a solid color to me. Do I really want to... I can bring it on to some other monitors. Check it out. Check it out. It sure looks like a solid color. So it's like, why is that? Is the... Well, my thought is... As it bends, so it's bending more and more extreme, that eventually... Yeah, no, that doesn't make sense. So if I color, I'm going to color pick the image really quick. I'm going to color pick the screenshot I took, and I know it's probably going to be that first air color. So we got the 333, 333. We're going to color sample again. 333, 333, color sample again. Yeah, so it is a solid block of color, and it's all threes. So, yes. Cancel. Okay, so if we look at our code, right, and we go Control F, and we go 0x333, and try to find that. Oh, hey, look, we got some color codes, and we can kind of see, like, well, what is that all about, right? Well, first of all, we know that magenta for out of bounds is no longer true, right? It's just gray. And 3333 is the first one, right? It is, everything has evaluated to 0. So the layer has evaluated to 0. The checker color value has also evaluated to 0. And if we're in bounds or out of bounds, that value has also evaluated to 0. So everything is evaluated to 0. So like we're out of bounds, and so I'm highly skeptical that so I think the math here is solid. This math for figuring out where we are, that's solid, but getting the actual input. So the input values for here, how we're calculating these values, 1, 2, and 3, something is wrong with how we're calculating those values to just get 0 for all of them, right? Even if yeah, because even with the warping that we're doing, we're not expecting a whole bunch of values to just be compacted into one voxel, right? Because the only way we could get this solid area like that solid stripe, is if a whole bunch of pieces of our non-planar plane are somehow packed into the exact same voxel, right? And they just don't cross any border. And I just highly doubt that that's the case. So let's try to figure out where this is going wrong. Where is, and it seems like it's all going wrong, right? It's the, right? Because if it was out, if it's still getting 0, so something about, so let's see this, and then it's a plus and a plus. I don't see these values like canceling each other out, like, right, if these were negatives for some reason. Well, if they were negatives, yeah, there could be some creative canceling out, but I just don't see it, like, doing that, right? I don't know. Let's take a look. So lay equals I mod 32 TZ, and then the checker pattern. And then what about this has value? This has is like a define for voxcur.has, and it's a uint, and it's being set to 0. So hold on, has. So where is that getting set? Because it's like we enter and render scene, right? And we've blanked this out. We've blanked out this vox thing. And then somewhere we're setting the has value. And it looks like, oh, in get vox right here. We're going to set that has value. It's the only place it could be set, right? So if we look at... yeah, so let's look at how we're kind of like getting the has value, because I think the has value... yeah, I don't know. There's a lot of stuff here. So we got point in space, and then we got this like ray world normal, right? And we're gonna use that to get some voxel information about like what voxel we're touching and whatever. I don't know exactly. First voxel query needed is what it says. So current voxel cell. So we set it to -1. So this val. Yeah, so the voxel this is when we're inside of our like voxel map. And that's sensible, right? And otherwise, if we're not inside the voxel volume, we'll do this, right? So that there's nothing like weird going on there. So the other thought is that that maybe there's some type of consequence with the warping of my non-planar plane that I'm just not thinking of, where it's like it's totally a thing that can happen, and I'm it's unexpected what I'm seeing, but maybe what I'm seeing is correct. But just I really highly doubt that. Okay, so we're going to say that, that's probably correct. Now, the other thing that could happen is if this never gets called, right? Is there any point at which we break out before we call this, right? Because then vox 000, yeah, if somehow we were in here, and we never do this loop here for some reason, then that could happen. But how would that would never happen, would it? Or would it? So if we look at where we're breaking, we have... okay, and... no, so this always gets set. Now the question is the yeah, I mean that looks correct. if we never marched to the voxel, right? If we never did this, then that would happen. So right now we're not really using the normal, right? We're just using this like ray world coordinate, this XYZ. We're taking the camera, we're taking the normal, and then we're taking the distance to the next, which is 0, right? We start out at 0, right? So we're going to just start out where that camera position is, the camera, the ray world coordinate, which is on that non-planar surface that we're using to cut through our geometry. We just want to know why could there be a value of XYZ that just is doing something weird? So let's take that. So the first coordinate in here, this XYZ, where is it used, and is there anything weird that could be happening? So once again, I'm looking at this and going, well, what if the so figuring out what tile you're in, how does that work when we go negative, right? Does this math make sense with negative values? And then even if this math makes sense for negative values, could it be that it gets a negative tile value, and if the value is negative, it still wouldn't be in this range. This is just giving us information about if we have a voxel or not. So it's actually right here where that's happening, where that...
Jamie?
Yeah?
Go get Frankie.
Okay.
Now.
Alright. Okay, I gotta go.